Hello students, so today we will discuss about some important compounds of boron. So first is borax and it is most important compound of boron. Its formula is Na2B4O7 10H2O, but it contains tetranuclear unit. That means it is a complex compound which has 4 centers or nucleus. As we can see, it is mentioned as B4O5. It has 4 boron center or nucleus. That's why it is mentioned tetranuclear unit. So that's why correct formula will be Na2B4O5OH4 times 8H2O. That means Na plus are attached as ionic bond and all of the mentioned in square bracket. They have coordinate covalent bonding between it. When dissolved in water, it produces alkaline solution because it produces NaOH and H3BO3 or orthoboric acid. It is weak acid, so because of stronger nature of basic NaOH, overall solution will become basic. On heating, it loses water and on further heating, first it swells up, then it will turn into transparent liquid which solidifies into glass-like material, and it is known as borax bead. Now this is very important point because we will use this in our inorganic qualitative analysis practical. In laboratory you will be given three different type of practicals: volumetric titration, inorganic qualitative analysis, and organic qualitative analysis. In volumetric titration, compound will be known and you have to find the concentration of given compound. That means concentration will be unknown and compound will be known. In organic qualitative analysis, you will be provided an organic compound and your target is to find that compound. And same goes with inorganic qualitative analysis. You will be provided with inorganic compound which contains one positive ion, one negative ion, and your target is to find which positive and which negative ions are present. So to find certain positive ion, we can use this borax bead test. Reaction is mentioned in this equation. Now metaborates of many transition metal, that means D block elements, have characteristic colors and therefore borax bead test can use to identify them in laboratory. Okay, so that means it can be used in inorganic qualitative analysis. If some of the unknown metals are present, transition metals, then using borax bead test we can identify which metal is provided to you based on the color of bead. Each and every transition metal have their own specific color, so based on the color we can identify it. Next is orthoboric acid, and preparation of orthoboric acid is as mentioned. We can prepare it from borax. With HCl it will turn into orthoboric acid. Along with it will produce NaCl. It can be also formed with the hydrolysis of most boron compounds, and it has layer structure in which BO3 units are joined with hydrogen bondings as mentioned in this figure. So as we can see, we have BOH thrice molecules attached with each other via hydrogen bonding. This solid line represents permanent attachment between oxygen and hydrogen, and this dotted line represents hydrogen bonding between oxygen and hydrogens. In this planar structure we can see we have a whole BOH thrice molecule mentioned in circle, and each oxygen is attached with two different hydrogen, one with permanent bonding as we can see here and one with hydrogen bonding as we can see here. Same goes with hydrogen. Hydrogen is attached with two different oxygen, one is permanent bonding as we can see between these two, and one with hydrogen bonding as you can see between these two. Boric acid is weak monobasic acid, that means it can produce only one conjugate base, and it is not protonic acid but act as Lewis acid. Now that means protonic acid usually releases H plus, and Lewis acid gives acidic character by accepting electron pair. We already discussed earlier that these compounds are electron deficient compound. That means they do not have complete octet, and that's why they have empty orbitals. Because of that, they can accept electron pairs and they can act as Lewis acid. So same reaction is mentioned here with water. It accepts electron pair from the water, and that's why it will act as acid and water acts as base. On heating, first it loses some of the hydrogens and oxygen. That means in first step we can see one water molecule is removed and it yields metaboric acid, and on further heating it produces boric oxide. Next compound is diborane. So as mentioned earlier in case of AlCl3, AlCl3 will be present in form of dimer. That means two different AlCl3 molecules will combine with each other because of incomplete octet or because of electron deficiency. Same will goes with B2H6. Here we have two BH3 molecules attached with each other because of electron deficiency, and it is simplest boron hydride. So it is prepared by treating boron trifluoride with LiLH4 lithium aluminum hydride, which is one of the strongest reducing agent, and that's why it is able to remove fluorine and it will add hydrogen. And you from BF3 you will get B2H6. In laboratory we can prepare it from the oxidation of sodium borohydride with iodine, and in industrial scale we can use BF3 with NaH, which produces B2H6. Now this compound is highly toxic and its boiling point is very low, 180 Kelvin, so it will be present in form of gas. It catches fire spontaneously, and upon exposure to air it releases comparatively high amount of energy. So as mentioned here, B2H6 with oxygen produces B2O3, that means oxide, and it releases 1976 kilojoules of energy per mole. This amount of energy is very high. With water it produces boric acid, and with Lewis bases it undergoes cleavage reaction to give boron adducts. As mentioned, B2H6 with NMe, now Me represents methyl groups, it produces BH3NMe3. So as we already know, boron hydride is electron deficient compound, so it has empty orbital, that's why it can accept electron pair which is already present in nitrogen, and that's why these type of bonds occurs. Same goes with carbon monoxide. With carbon monoxide again it can accept electron pair and it can act as Lewis acid. This compound is three-dimensional compound, and some of the elements are in same plane. That means two borons and two hydrogens attached with boron present at the end, they are in same plane. But bridge hydrogen, that means hydrogen present between two borons, are above and below the plane. Now these hydrogens do not have permanent or complete single bonding with single boron. Instead it has 1 by 2 bonds with both of the boron. That's why they are referred as bridge atoms, because they are present as a bridge between two different boron. And same goes with boron. Boron has three permanent bondings, one with this hydrogen, second with this hydrogen. And now between two bridge it has 1 by 2 bonds with each hydrogen, and same goes with second boron. That means coordination number of boron will be 3 in this case. And at the same time we can say that it has coordination number 4, because with around a single boron all the 4 hydrogens are arranged tetrahedrally. That means borons will be sp3 hybridized in this case, and this type of bonds occurs because of deficiency of electrons. Boron also forms a series of hydroborates. The most important one is tetrahedral BH4 minus ion. Now tetrahydroborates are of several metals are known, and lithium and sodium tetrahydroborates are also known as borohydrides. Now this lithium and sodium hydrides are reducing agent, and they are used for as a raw material to produce some metal borohydrides, and they can be prepared with reaction between metal hydrides and B2H6, and as the reaction is mentioned, it produces metal borohydrides. And the bridge hydrogen bonds are also referred as banana bonds in diborane because it appears to be like a shape of banana. Actual shape will be different, but we can assume attachment of each hydrogen with two different boron will make them show something